Perfect. Well, who wants to start us off this week?
I can start. I don't have much to add. It's just other than yeah. So I've built mumps on one of our 128 core machines, and did some testing, and yeah, it scales beautifully.
Oh, nice.
Yeah, if we have big problems using mumps on however many cores you have, and it's seeming that the bigger the problem, the better it scales at higher core too.
Nice.
I've got a little charts. Maybe I'll post them on the dev channel there on Slack. Yeah, and then Glenn did some efficiency, and yeah, we're getting like 80% efficiency after like 40 some cores, and yeah, just going up from there. I've been having problems with the PyMumps wrapper. I was digging around. I don't know. I haven't really played with Python too much, so I'm kind of in there stumbling around trying to make things work. Joe went in yesterday, and the wizard that he is was like, oh yeah, I can get this to work. Oh yeah, multiple right-hand sides, everything was going. So I think he might be the magic key right there to get it into SimPEG. Yeah, he was going to test it on the Windows machine, and then he was going to let me know where to go from there.
Oh, that's really exciting.
Yeah. I'm still fighting with it. I've actually got one colleague on writing a Fortran or like the F2 Pi wrapper for it. Yeah, just to see if we can go that way to get some more testing done. But either way, I think we've got something going that we'll get it into SimPEG.
That's really exciting.
Yeah.
That's great. Huh.
Yeah,
So,
Joe went in there so slick. Made me feel quite defeated, actually. But yeah, that's how it goes.
don't tell him.
Yeah.
He doesn't need to know that. So
that Lindsay's recording this.
oh, that's true.
We can break that part.
Lindsay has the magic hands to kind of things.
Nice. And I did all the testing with frequency domain stuff. So it's all the Z mumps is the double complex version. Yeah, so we should be good to go. For sure.
Oh, great. So, like, if somebody wants to use that, then that as an individual need to compile that Fortran compiler and basically use PyMumps to link. Is that
You might not have to worry about the Fortran compiler if Joe gets his side, or like if Joe's already tested and said it's working. So I don't think he had to go through Fortran stuff at all.
Oh, I see.
But the other angle that I'm working on, yeah, you would have to. But the other cool thing is Joe and I Joe was pointed me at this repository, CondaForge repository, and it looks like they have one that's pretty close to what I built. It's version 5.1 something.
Okay.
But I looked at the make file, and it seems to be using a lot of the same things like Parametes and PC Torch or Scotch.
Nice.
Sorry, Scotch. So
Nice.
yeah, it should be actually easy to install too if you're just through Conda.
I see. So basically, we can use Conda to install mumps and then link
the wrapper.
Right.
Would you, when you think it's the right timing to try this out? I mean, I would be super game to try this on Google. If you have like sort of a set of steps of just like give this a shot at the high level.
Yeah.
Yeah, because that would be awesome.
Okay, cool. Yeah, I have a recipe for the one that I've made already. It's just Joe's having more success with the version 5.1. So whatever one we get to first, we'll get a hold of you.
That's awesome. That's really, really exciting. I feel like that's going to unlock some really cool stuff and actually being able to scale. And yeah, wow, cool.
It's gonna be really interesting because even like we did some testing with Loke and we were comparing it with the Paradiso MKL and it was very comparable. So it's really going to be one of the faster solvers out there that we can have usage.
That's great.
That's great. And that time. Oh, go ahead.
John, have you made a comparison with Paradiso?
I did, yeah, actually. Yeah, it's about. So yesterday on that model, it was about say I think it was 230 some thousand element model, and Paradiso took 1.46 with access to those 120 cores, and I got mumps down to 0.22 milliseconds.
Oh wow!
Yeah, But then again, the Paradiso isn't really using all those cores, so it's really just stuck down to a few. So it's not quite the fair comparison, other than mumps can use it all, and if you can use it all, it's fast.
Right, right. So if you set the like a number of cores that like a mumps is using,
yeah.
If you do a one-to-one comparison, well, it's not quite one-to-one, but let's say if you set a single core,
yeah.
Mumps,
So in that case, yeah. Oh, so in that case, I got where was that number? Point. Oh no, wait. Oh no, sorry, I forgot a 0 there. Okay, no, I was reading my wrong chart. So at 128, it solves in 0.05 milliseconds, whereas with one core, it's 0.22. So it's even faster on like the single core than Paradiso.
Oh, wow, that's great. And were you using like a 2D mesh or a 3D mesh?
3D mesh, yeah. It's only about 56,000 elements, or sorry, yeah, I think elements or cells. Sorry. Yeah.
That's great. That's great. Oh, have you tested like a kind of maximum size that you could run? Like,
that's what I was hoping to, like with the wrappers, we can have better access to that. Because right now, if I do something with Paradiso, I have to write it to like a ASCII file so that I can bring it into the mump side. And as soon as you get into like 100,000 cells, it takes like a day to write that ASCII file. So, so I was hoping to do the wrappers and then do the full test on the large problems. Say the CSEM one there, Lindsay, that's a pretty big one, isn't it? Or,
yeah. I mean, so the base mesh, I think, is like 9 million cells. So I was, of course, going to reduce that with the Octree, but it's still probably going to be on the order of several million cells.
So that would be an ultimate test for sure.
Wow. That's big. Not
But that's also like, I mean, a completely uniform mesh. So there's stuff we can do to trim that down, but it's still going to end up being probably at least 2 million cells. So we'll see what we can do with that.
Yeah. I've got a couple models in about the 2 million range that I was going to throw at it and just see.
And Lindsay got a pretty big computer, right? Like big RAM computer.
Yeah. So I've been running it on Google, and you can get a high memory node that's 128 gigs of RAM. So
I see. If you need one, I got pretty big one, like a 500 meg or 500 gig or something like that.
Okay, wow.
Yeah, it's well, it's shared, so somebody may use some portion, but it's pretty big memory, so if you need a really big one.
Cool. Okay, that's good to know. Excellent. That's really exciting, John.
Once I get there, and with Joe's help.
Fair enough. Cool. Do you have any other things, or that's enough things for us to say?
Yeah. Other than that, I'm just back on user interface stuff, squashing some bugs, and hey, banging my head against the wall.
Fair enough. Fair enough. Cool. Thibaut, do you have any updates you want to share? A paper.
Oh yeah. Congrats! Yeah, it got accepted for this time for the GeoSci paper, like for the joint methodology. So I will send all the things this afternoon. Doesn't seem we got any revision. I don't know even if it seems like the editor just looked at it and said like, yeah, that's fine.
I was looking down, there was nothing there. So yeah, I think good to go. Good job. Congrats.
Yeah. No revision. Good. No revision. Good news. Yeah. So yeah, but I haven't spent much time on SimPEG the last week. I was mostly like reading papers and like following some of the tutorial with GeoSci. I was actually also looking at the materials that Dieter put online through MPyMod2, and that's pretty good too. He has some serious geological models there. So yeah, I was looking at that, and I'm thinking too. More a question at the moment, but so I will probably be defending early September. and it seems like a real hassle to get like an audience to the it's going to be online for the for the defense, and it seems a real hassle with grad studies to get the an audience, etc. They share it only with the committee and the defendant, and you need to request individually to be sent out the link, etc. And they handle the like grad study is handling the Zoom apparently, so I don't think they are recording either. So I was thinking that anyway, I would probably like to do like a fake run before doing the defense, like run through the slide and to have like some feedbacks before that. So I was thinking either we do that as a SimPEG meeting or at some other point. And if anybody is willing to be an audience for like a personal training for the defense, and then we can record that thing as like to keep a track of that presentation.
Yeah, for sure. We can definitely either take a SimPEG meeting or do something on a different day, whatever works. So feel free to just like claim a meeting as yours when you're ready to do that.
Okay, cool. Yeah, so we'll probably be like in 3 weeks, I guess, something like that. Yeah, we're still trying to figure out a date at the moment, but yeah, it's looking pretty well for early September.
Excellent.
What's the title of your thesis, Thibaut?
Oh God, like a long one. Probably went for like a framework for joint petrophysical and for a framework for joint petrophysically and geologically guided inversion.
Sounds pretty cool. I would be very interested to see.
Yeah, I can share the thesis, and if you like the PDF of the thesis, if you wish, it's on Google Drive. Like it's. Hopefully, I will have not too many corrections on the thesis. Anyway, all chapters will have been published by the time I get my correction. So.
Excellent. That's exciting, Thibaut. Don, do you have any updates?
No, I think for me, I was work, and taking some vacation. It's kind of that time of the year, right?
What are you doing for vacation?
I just went back from Banfield with Chantal. It was epic. We saw whales, saw bears. Chantal caught a shark. It was a pretty epic adventure. So yeah, no coding.
That's fair. Sagi, do you have any updates?
No vacation here, but spend more time with my son. Nothing really particular on the SimPEG, and I just finalized the last project in Stanford. So now I got a little bit more time, and yes, I'm looking forward to revisit Devin's refactor for 1D code. And also, I want to spend more time these days to kind of package up what's we developed here in Stanford. So yeah, I'm looking forward to have a bit more time in these days. So yeah, that's where I am. And one thing that I was thinking was developing a 2D MT code, because like it feels like I mean we're pushing through to develop the 3D code, but in terms of thinking about the use, 2D code could still be very useful. It may have some problems, absolutely, but it could be still quite useful. So yeah, I was just kind of curious, like, is there a need of having 2D code? Because I'm not, on my end, I don't have that much need at this point, but if there's a need, and yeah, it's probably worthwhile to revamp and develop.
Well, I've found that a lot of tenders that come out for projects, people still, or for MT projects, it's 2D. They want their 2D sections. They're written in the contracts. So I think if on a commercial side of things, people definitely still like the 2D codes and still like to use them to interpret.
Great, great. Yeah, so it seems like an interesting avenue. And I don't know, on my end, I mean, developing 2D MT code itself is not very interesting in the research side. I mean, it's done. But I guess if you think about combining with other things like T-Bose joint inversion, for instance, I mean, having a tool set like that will be very helpful. And it's actually, it is fast. So if you can have a fast code like that and useful, that'll be, I thought that's useful. So I'll probably jump in and do something for that.
If you need a hand, Soggy, I'll definitely put some time to help for sure.
Yeah, having a good example will be awesome. I'll ping you later.
Excellent.
Well, always having like a lower dimensionality inverse code is good, right? I mean, look how valuable the 1D code is for just, you know, analyzing data, quality control, getting a first pass about things. And same is true with the MT, and there's still a lot of data that's just acquired, you know, with lines of MT data. And the other thing is, if it's, you know, then you can also experiment with, you know, boundary conditions, right? So I think it's a nice, you know, framework in which to work and to pose a whole bunch of questions before you actually go to 3D.
Yep. And yeah, it's a good point. And I think honestly, as like when I'm thinking about it myself as an invert, like running an invert person who are running an inversion, having a fast code is very important because I mean, if you need to wait a couple of days to run inversion and your mindset is gone. So if you have like, let's say, like a couple of minutes to run the inversion and get a result and think about what it's supposed to be and what's your sort of expectation and change the parameter, that process, like, I think that speed is very important in that process. Otherwise, you lose kind of momentum, I thought. So yes, I think still lower dimension code kind of has a value in that way. Anyway, just a thought.
Yeah, that would be really exciting, Soggy. Doug, do you have any updates?
Oh, not really, but we're pleased that we've got all of the stuff in with the GWB. So thanks everybody who contributed to that. So that's kind of nice to get that off, and now we can concentrate on, you know, we've got some presentations at SEG and AGU. Actually, presentations at SEG was that middle of August that we were supposed to?
They pushed it back to September 1st, which is actually still not that far away.
Okay, that's good. Yes, and that's sort of been the main preoccupation. After this is over, Soggy and Dom, maybe we can continue chatting about the LP, LQ inversion to kind of look at that other paper, but it's kind of related to SimPEG, but different matters. So we might report back later on that.
On the SEG front, so yeah, I don't know if you guys saw the emails flying by, but so SEG finally got it to reason and decided to go full online, right? So Jenny Cole sent an email to all the post-convention people and said that they will review how they want to do this, and it looks like it's going to be a full Zoom, probably interactive one. So in the end, after fighting with them, you might get what we wanted in the end. So we'll see. We'll just wait. They promised an update within a few days.
That's good.
Okay, yeah. So the SEG is going full virtual then, is it, or
full virtual? Yeah.
When
they
did
finally decided. Sorry, I'll forward the email the emails that I got, and then that it came out last week, I believe. Last week, yeah.
Yeah, it was pretty recent.
Because, well, I was first author on one paper. So, I mean, sometimes they'll just send something to a first author. Sagi, did you get any information about this?
I haven't heard of that, but there's big possibility that I just didn't read that email, so I am not sure. But I haven't recognized that, so you're not alone.
Okay. Oh, anyway, that's good. That's a good move for them.
Yeah, so on my end, I've been working on sort of refining the layered model for the paper with Dieter. And so I'm going to send that hopefully this afternoon. And if folks are willing to take a look, if anyone's willing to take a look and see if there's improvements you think could be made, I would certainly appreciate input. I basically got it down to the point where we're sort of like median 3% error, which is pretty good. But I think we should still be able to drive it down further. And so if anyone has ideas when you look at the mesh or the interpolation or things like that, I'd be happy to sort of walk through what I've done, but would appreciate a fresh set of eyes on it, because I've been staring at it, twiddling knobs to see what I can do. But yeah, another perspective would be appreciated.
So median 3% seems like a. Do you have like an outliers of pretty large? Just curious what the median seems like we usually compute the mean or L square like RMS error.
In this case though, we have 0 crossings.
Okay.
And so like the mean, you're gonna have some of those are gonna be just artificially shifted from that. So there aren't huge outliers, but it's really those 0 crossings that cause the outliers. So.
Got it. But other than that, it's pretty low.
Yeah. So I'll send that around hopefully this afternoon. And then we'll be sort of working on getting the next example, which will be this Marlin one, which will be pretty big. I'm going to start by just like trying to get a really coarse volume averaged version of it just up and running so that I've got kind of the workflow in place. And then hopefully by the time I've got that done, then maybe the mumps will all converge and be able to start running some big examples there. And then I guess some of the other things. So on the Swung Slack, there's again been sort of the suggestion of thinking through, do we want to merge Slacks? Do we want to have some joint channels? What do we potentially want to do there? My sort of initial suggestion would be, I think in some ways it might be kind of cool to merge some of the methods focused channels. So like have EM be back and forth and have potential field be back and forth, and sort of more places where like that, yeah, it's a methods-based conversation. At this point, I don't know if we want like the meetings stuff or the dev channel on there, but there might be some things to think through, just like how we might want to merge or like open up some more communication lines with that community. I don't know if others have thoughts on that or initial reactions on that.
What does it mean merge, Lindsay? So let's say EM channel. What does merging means?
So there's a couple things we could do. One, we could just get rid of the EM channel on SimPEG and then just have those conversations in Swan. The other thing that we can do is, I think there's a concept of joint channels between Slack groups. And so if something is sent in the SimPEG EM Slack, it would show up also in the Swung Slack because they're like one and the same thing, which might be nice. Yeah.
Yeah. At this point, I don't have that too much thought, but the letter option seems better rather than moving EM channel into Swung.
Oh, you disappeared mid-sentence. Fair enough. Okay. Okay. Yeah, so okay, that's one to think about and we can maybe revisit. Other things. Well, I guess Joe, do you have any?
Hey, yeah, sorry. For some reason I slipped it at 10:30 because I'm like, I've been used to it being at 11:30 for so long, at least in my own time period. I was like, oh yeah. And I was like, okay, it's oh yeah. Okay, sorry guys, I was a little late. I see John talked a little bit about the mumps stuff. I was playing around with that yesterday. And I wrote my own little Python or Python wrappers for it myself. I was able to get it working with the
Sorry, I had a connection problem.
I was able to get it working with the CondaForge mumps installation with the MPI version that they have. Looking into it more and looking at more at how it's interfaced and how it interacts with things, unfortunately we will not be able to like use it. We're gonna have the same problems with Dask interacting with it that we had with Paradiso. It's essentially it's not thread safe to call solve function for multiple things for a given object, and there's no way we can get around that. It seems like a lot of these solver packages are kind of built in that similar manner, and that okay, you have one long object, one structure that has a bunch of pointers to things to it, and that's what you pass around everywhere. So what's essentially happening with mumps is that okay, there's one object that has a pointers to every variable that you need to pass to the functions that operate on it. So when you solve a right-hand side, you have this variable or this like object that represents everything that you pass to it. So when you factorize it, you give it the I, J, and A values of the matrix, right? And then when you solve it, that same object also has like right-hand side pointers. So every time you solve it, you have to assign your data to that pointer, and then it uses that information. So there's no way to like do that with multiple right-hand sides in parallel up from outside the function, because it will keep overriding the same pointer.
But we can iterate that, right, Joe? Just like rather than passing the full right-hand side, we can just iterate over, right?
Right, but we can't call them. We can't call them from the same or from different threads from the same process at the same time. The only way we can really parallelize it is with some sort of MPI processes or.
Oh, I see. Oh, so you're thinking about the parallelization.
Yeah.
I see.
Yeah. It's parallelizing the call to the solver, and I don't know. And that's something that we were having issues with Paradiso, is the same kind of thing, is that multiple calls to the solver, to the solve operation from different threads of the same process were causing clashes, like memory clashes and overwriting stuff. And thinking back to more about how that's implemented, and it's basically implemented the exact same way. Like you assign pointers to things. I don't know. It just seems like it's like a leftover of old 90s implementations of things before there were, for object orientedness got around to everywhere. I'm not sure.